Let's go surfing. Here we are, chapter 12, lesson number 5, solving trig equations. If you're not that confident with solving trig equations, you may wish to look back at the trig chapter, chapter 5, and look over the solving equations there. What these ones are doing is they're just asking you to use the wave function, first of all, to have something in the form of k cos or sine x plus or minus alpha, and then from there, just solve an equation because it will be set equal to something. So, let's try a few examples. So A, express 5 sine x minus 12 cos x in the form k sine x minus alpha. B, hence solve the equation where that equals 6.5 in the interval with x between 0 and 360. For each of these then, it is a wave function question. We're doing the exact same thing that we have done in the other lessons. All we want to do is we're wanting to write this in this form, first of all. So you know you're using your addition formula. So the first thing you would do is you would set them equal. If you want more of an explanation, maybe look back at the other examples. But you should know this by now if you have looked at the other videos. First of all, set them equal. From there, you're going to have k bracket expand sine x minus alpha, multiply out the brackets, and then from there, you want to find the values of k cos alpha and k sine alpha. So, do the same thing as before. Take the coefficient of cos x. We've got a negative sine alpha. Take the coefficient of cos x here. We've got a negative 12, which means then that negative k sine alpha is going to be equal to negative 12. And if that was the case, multiply both sides by negative 1, and k sine alpha would be equal to 12. After that, you want the coefficient of sine x. So the coefficient of sine x here is k cos alpha. Coefficient of sine x here is 5. So you know k cos alpha must be equal to 5. Woo! From there, after you know a and b, or k cos alpha and k sine alpha, you need to work out k and alpha. You're using the same equations that we have done in the other lessons. So to work out k, it's the square root of a squared plus b squared. So it's the square root of 5 squared plus 12 squared. Square root of 144, add the 25, 169, which gives you 13. To find alpha, it's going to be k sine alpha over k cos alpha, which will give us 12 over 5. The k's cancel out, and sine over cos is tan. From there, you would use the inverse tan of 12 over 5, and that works out to be 67.4 degrees. Remember, you need to check which quadrant you are using, so you want to think, right, well, cos here is a positive, and cos is a positive here, and here. Sine is a positive, sine is 12, that's a positive number, so that's a positive here and here. And tan alpha, well, that's a positive number, and tan is a positive here and here. So you want to use the acute angle, meaning then that alpha will be 67.4 degrees. From there then, we have 13 sine x minus, that's 67.4. That is something that we have been over before. Really what we're doing now is we're just taking it one step further, and we then want to solve the equation where that equals 6.5. So the first thing we had to do is we had to write it in the form k sine x minus alpha. So writing it in that form, we had 13 sine x minus 67.4. And we know then that if it's equal to 6.5, we can't solve it when it's written like this, but we could set the 13 sine x minus 67.4 equal to the 6.5. And then from there, you can solve it. So starting to solve it, max, what do you do first? Good, divide by 13. So 6.5 divided by 13 gives you a half. And then from there, good, sine to the minus 1 of a half. So if you work out sine to the minus 1 of a half, it's just one of your exact values. That gives you 30 degrees. Just remember, you are wanting to think about the limits. So x is between 0 and 360. But here, you've got x minus 67.4. So you're looking for all the answers between. Well, you'd work that out. Take the 67.4 away from 0. Take the 67.4 away from 360. So you want the answers between negative 67.4 and 292.6. For that then, if you think about cast, you will be using a quadrant A and S. So the first and the second quadrant. So you've got 30 degrees, or 180 minus that, 150. From there, just add and subtract 360 to both of these values and check if there's anything else that comes up in this interval with negative 67.4 and 292.6. There's not. So from there, you can add 67.4 to both answers, and that will be your values for x. Really, this lesson is just bringing these two parts together using the wave function and solving trig equations. If you're unsure about either of them, you're best going back to those lessons. But we'll do a few more examples anyway. Example 2, express 3 cos x plus 5 sin x in the form k cos x minus alpha. And then hence solve that equation where it's equal to 4. We know we can't solve it just now when it's equal to 4. We first of all have to write this in the form k cos x minus alpha. So to do that, again, you're using the addition formulae. So set them equal first of all. So 3 cos x plus 5 sin x equals k cos x minus alpha. From there you can expand, so you've got k brackets, expand the cos x minus alpha, and you get cos, sin, multiply by k, and that is what you will get. From there you then want to find the values of k cos alpha and k sin alpha, so take the coefficients of cos x. So the coefficient of cos x here is 3, and here is k cos alpha, so we know k cos alpha must be equal to 3. Do the same thing with sin x. So the coefficient of sin x is k sin alpha. Coefficient here of sin x is 5. So we know then that k sin alpha must be equal to 5. So we've found k cos alpha and k sin alpha, or in other words, a and b. From there, well, you have to find out k and alpha. You're doing the same thing. To work out k, it's the square root of a squared plus b squared. So that will give us the square root of 34. And we'll just leave it as that. Don't bother writing it as a decimal, just leave it as an exact value. From there to get alpha, well, it's k sin alpha over k cos alpha, so that will then equal 5 over 3. The k's will cancel out, and sin over cos is equal to tan. From there, it's 5/3. Inverse tan of 5/3 gives us 59.0 degrees. And again, you're thinking about the quadrants. Up here, cos is 3, is a positive number, so cos is a positive in A and C. Sin is a positive number as well, and sin is a positive in A and S. And triple check, tan alpha is 5/3, that's a positive number, and tan is a positive here and here. So, you know it's the first quadrant, it's the acute angle, it's your calculator answer of the 59.0 degrees. Therefore, we were asked to write it in the form, and that is what we end up getting. So we replace the k with root 34 and alpha with 59.0. After that, we then have to solve it. So hence solve the equation 3 cos x plus 5 sin x equals 4. We know first of all that we had the 3 cos x plus 5 sin x written in this form. That is what we were doing for part A. So we know then that really if this is equal to 4, then really this part here that's equal to will also be equal to 4. From there, what would you do? Good, divide by root 34. Brilliant, so you get 4 over root 34. And then you'd work out cos to the minus 1 of 4 over root 34. If you do that, you get 46.7 degrees. You need to think about the limits though. We've got 0 and 90. X is between 0 and 90. But here we've got x minus 59 degrees. So x minus 59 degrees would be 0 take away 59, you get negative 59. And 90 take away 59 is 31.0. So we're looking for all the answers between negative 59 and 31 for the x minus 59.0 part. So x take away 59.0, well, if you're using a cast here, well, you would have A for all, so you'd have the first quadrant of 46.7 degrees, and you'd have this quadrant here as well with 360 minus that 46.7, so you'd have 313.3. However, what's the problem with that, Chelsea? Good. Neither of those answers lie within this limit that you're wanting of the negative 59 and the 31. So how would you get the answers that lie between them? Olivia, help us out. Good. You just add and subtract 360 to these answers. So doing that then, if you add 360 onto the 46.7, well, you're getting something that's way over 31. It's already over. If you subtract 360 from 46.7, you're getting something a lot less than negative 59. So that will not work either. So let's take the 313.3. If you add 360, well, you're definitely over this limit. But if you subtract 360, you end up getting negative 46.7. That's just 313.3 take away 360 degrees. Really then, this answer is the one that you want. I'll work through it with these ones in red, just to show you that this does not work. But if you add the 59.0 onto these answers, you'll end up with 105.7, you'll get 372.3, and the one that you want, the only one really that you need to write, is this, with 12.3, if you add on 59 degrees. So these answers here, you do not need them. They're outside the limit that you want. I'm just keeping them there to show you. It's these ones here in blue that you will use. So x equals 12.3 will be your only answer. And just double check that. You're asked to solve it in the interval with 0 and 90, and your 12.3 is between them. So that is your answer. Example 3. Express root 3 cos x plus sin x in the form k cos x minus alpha, and hence solve the equation where that equals root 2 in the interval with x between 0 and 2 pi. Woo, radians! So, first thing you want to do is you want to set them equal, as we have done for the previous examples. From there, similar to them, you would expand this cos x minus alpha. So you've got k brackets with that expanded, multiply out the brackets, so you end up with k cos x cos alpha plus k sin x sin alpha. From there you need to find the values of k cos alpha and k sin alpha. So do that the same way, take the coefficient of cos x and the coefficient of cos x here. Doing that on the left hand side we've got root 3, on the right hand side we've got k cos alpha, so we know then that k cos alpha is equal to root 3. Do the same thing with sin x. Coefficient of sin x here is k sin alpha. Coefficient of sin x here, how many have we got? 1! Good, so it's going to be 1. So your k sin alpha must be equal to 1. From that then, we find the values of k and alpha. So to get k, it's the square root of a squared plus b squared, which is the square root of root 3 squared plus 1 squared. Remember, root 3 squared is root 3 times root 3, which is root 9, which is 3. Add on 1, which is 4, so it's the square root of 4, which is 2. To work out alpha, it's k sin alpha over k cos alpha, so that's 1 over root 3. And you would then cancel the k's, and sin over cos is equal to tan. So then you would take tan to the minus 1 of 1 over root 3, and I'm sure you all know that is good, well done, it's 30 degrees. But we do want radians, so that would be brilliant, pi over 6. Excellent. You do need to use Casto to work out which quadrant you are using. Cos here is a positive number, root 3 is positive, and cos is a positive in A and C. Sin is a positive number, it's just 1, and sin is a positive in S and A. And tan alpha, 1 over root 3 is a positive number, and that's a positive in T and A. Look for 3 ticks. If you don't have 3 ticks, you've made a mistake. We're just wanting the calculator answer, the acute angle, meaning then that alpha is going to be pi over 6, or 30 degrees. From there then, you are asked to write it in the form, so we replace k with 2 and replace alpha with pi over 6. After that, well, for part B, we had to solve the equation where root 3 cos x plus sin x equals root 2. For that then, x is going to be between 0 and 2 pi. We know that root 3 cos x plus sin x is equal to this right hand side. So we know then that this right hand side will be equal to root 2. From there you can divide by root 2, you can divide by 2, sorry, so you will end up with root 2 over 2, which equals 1 over root 2, dividing the top and the bottom by root 2. So that gives you this, and then from there if you work out cos to the minus 1 of 1 over root 2, what would that be? Brilliant, that gives you pi over 4, or 45 degrees. Once again, you do need to think about the limits. We're wanting x between 0 and 2 pi, but we have x minus pi over 6. Meaning then, if we have 0 take away pi over 6, we'd be looking for an answer between negative pi over 6. And if you take pi over 6 away from 2 pi, we get 11 pi over 6. So we're now looking for all the answers between negative pi over 6 and 11 pi over 6. Or if you think about it in terms of degrees, you'd have negative 30 and 330. That is where you want all your answers. So you can then say that x minus pi over 6 would equal, and using cast, you will end up with pi over 4. Or, because it's cos, it's going to be 2 pi minus the pi over 4, which is 7 pi over 4. Add and subtract 2 pi to these answers. Look for any more values between the negative pi over 6 and the 11 pi over 6, or negative 30 and 330. You don't have anything else in there, so that is the only 2 values you will have. From there, to get x, you will add pi over 6 onto both of these values, and you can simplify that. Look for your lowest common denominator, and that will become 5 pi over 12, and then 23 pi over 12. If you're unsure about that, look back to the trig chapter, where you go into it in a little more depth. Example 4. Solve 2 cos 2x minus 3 sin 2x equals 1 for x between 0 and 360 degrees. So for this one, problem, we're not told how to set it out. We're not told to write it as sin x plus alpha or cos x minus alpha. So if we're not told that, what do you think we do, Mary Lou? Brilliant. You just want to pick whichever addition formula you like. So remember your addition formula, you do need to know these, or you need to know how to use them. They are in the formula sheet. I'm just going to pick one, but in place of x, we're going to have 2x, because it's cos 2x and sin 2x. So that will be equal to k cos 2x minus alpha. Again, you can use whichever one you like. You will still get the same answer. From there, expanding this right-hand side, so cos 2x minus alpha will become cos 2x cos alpha plus sin 2x sin alpha. And from there, you can multiply out the brackets, so you're just putting a k with each of these parts. After that, you know you have to find the values of k cos alpha and k sin alpha, so you do the same thing as we've done for all the other examples. Find the coefficient of cos 2x on the right-hand side, find the coefficient of cos 2x on the left-hand side. So on the right-hand side, we've got k cos alpha, and on the left, we've got 2. That's how many cos 2x's we've got. So you know then, k cos alpha must be equal to 2. Do the same thing with sin 2x. So sin 2x, the coefficient here is k sin alpha. The coefficient of sin 2x here is negative 3. Make sure you are taking that negative. From there, you know you have to find the values of k and alpha. So to work out k, you've got the square root of a squared plus b squared. So here you have the square root of 2 squared plus negative 3 squared. That will give us the square root of 4 add 9, which is root 13. Just leave it as the exact value. To work out alpha, we have k sin alpha over k cos alpha, which will give us a negative 3 over 2. The k's will cancel out. Sin over cos is tan, so tan alpha is negative 3 over 2. And from there you can work out tan to the minus 1. Remember though, don't use the negative, just miss that out and work out tan to the minus 1 of 3 over 2, the positive value. If you do that, you get 56.3 degrees, but you now have to think which quadrant would you use. So cos is 2, it's a positive number, and cos is a positive in A and C. Sin is a negative, that's negative 3, and sin is a positive in A and S, but it's a negative in T and C. After that, take tan, don't use tan to the minus 1, we use tan alpha. Tan alpha is negative 3 over 2, which is a negative number, and tan is positive in A and T, but it's a negative in S and C. Look for whichever quadrant has 3 ticks, in this case it is C, so you would have 360 degrees minus the calculator answer, your acute value. And that will give us alpha then to be 303.7 degrees. We were asked to write it in this form, or we weren't, but we had to write it in this form first of all in order to solve the equation. So we chose to write it as k cos 2x minus alpha. So replace k with root 13 and replace alpha with 303.7. So that is us having it in this form here, which makes it easy to then solve the equation when that equals 1. Because all we do is replace the left-hand side with the root 13 cos 2x minus 303.7. So we will end up with that right-hand side equals 1. From there, you know you have to divide by the root 13. And after that, well, because we've got it in the form of cos something equals 1 over root 13, we'd work out cos to the minus 1 of 1 over root 13. That will give us 73.9 degrees. After that though, think about the limits. You've got x, you're wanting it between 0 and 360 degrees, but we've got 2x minus 303.7, so you need to think about what you're wanting your answers to be between here. So 2x, you double that, you still have 0, take away 303.7, and we get negative 303.7. If you double this, double the 360, and again take away 303.7, and we get 416.3. So we're wanting all the values then for 2x, take away 303.7, between these two numbers. So using cast, first of all, you know that 2x minus the 303.7, if you're getting rid of cos here, that will equal, well, we've got 73.9, that is the acute angle, that is A, and we've also got 360 minus the 73.9 degrees. However, you're looking for all the values between negative 303 and 416, so add and subtract 360 onto both these answers to look for more. If you do through the 73.9 take away 360, you get negative 286.1. So that is in this range here, so that's fine. And if you do the 268.1 take away 360, you get negative 73.9, which again lies in this range. If you subtract 360 again, you don't get something in this range. And if you add 360 to these, then again, you don't have something in this range. So that is all the answers that you have. From there then, to get 2x, you know you would add 303.7 onto each of these values. That is what you will end up with. And after that, you will then divide by 2. So x is going to be 188.8, 294.9, 8.8, and 114.9 degrees. That will be the different values. If you were unsure about any of these, look back to possibly the trig chapter with solving equations, or look back to the first few lessons with the wave function. If you feel quite comfortable, give it a shot, mashing them both together. Yeah. Try some of these questions in the Heinemann Higher, page 318 onwards. It's exercise 16H. Good luck. Have fun. Bye.